Hi everyone, Alicia Panzarella here. Just for reference, I teach physics, so one of the major topics that we cover is forces. And one of the misconceptions with forces is that surface area affects the frictional force, and it does not. So how are we going to address that? At this point, students have already had a really robust background in free body diagrams. They know Newton's second law. They've worked with Newton's second law a lot. But now it's time to address the frictional force. So students are going to come in and have a poll everywhere that says what factors affect the force of friction. And I always get pretty consistent results. They tell me mass, weight, surface area, surface roughness, and occasionally I get angle, which is great because angle will allow us to differentiate this lab. So there's always a group or two that finishes way ahead of some others. So having that angle will allow us to address the concept of mass and weight a little bit better. One group or two groups will look at surface roughness. Other groups will look at surface area, and they will find that surface area does not have an effect. So why is that? Mostly this just comes from common experiences. Even if you think about your hands rubbing together, when you're a little kid, you're always told, oh, if you're cold, rub your hands together because you have more friction then. Well, little kids and us, we always rub our hands, fully together, our full palm, the biggest surface area. We don't do something like that. We don't do this. We use the full surface area because that's what gives us the most warmth. And sure, friction is doing that, but it's more so the fact that you have work being done. That work is transferring into thermal energy. But again, little kids or anybody sees, hey, I have the full surface area. Full surface area means more of a frictional force. Or, think about if you are going to walk over ice. Nobody tiptoes over ice. You typically walk flat-footed. So you're thinking, oh, well, I'm walking flat-footed. That means I have more surface area. When in reality, all you've done is created a bigger area. You've decreased the pressure, but the force is still going to stay the same. So a lot of it just comes from the fact that they don't have a concept of P is equal to F over A, or we haven't gotten to the energy portion yet to see, how does work actually happen? So for some of my older kids, this misconception is also going to come from the fact that they think bigger tires means more friction, which they're not wrong because bigger tires have a softer thread and that softer thread has a bigger coefficient of friction. So mu is bigger, but the surface area has absolutely nothing to do with it. So the force of friction is only affected by mu times Fn. So the mu, which is the roughness between the two surfaces, this is a value that is always less than 1 because it is a ratio between the force of friction divided by the normal force. And the normal force is always balanced by either the force of gravity or the force of gravity perpendicular if your object happens to be tilted. So the lab equipment that students are going to have for this are going to be given a constant velocity buggy car, variety of masses, variety of surfaces, a force scale, a container. So the ones that I have, unfortunately, are only going to provide for 3 data points, but you really want to have 5, and then a ramp and books for differentiation. So this is kind of the setup here. And we do want to have the constant velocity buggy car because we know that the applied force is going to equal the force of friction then. And then that inquiry lab, each group is going to determine their own essential question. So this is going to vary between the groups, but at some point, we're going to have every essential question tested. So we'll have, how is frictional force affected by the mass? How is it affected by the surface area? How is it affected by the surface roughness? So each group will have their essential question because, quite frankly, we don't have enough time for every single group to test every single essential question. So we're going to kind of use like the whole group aspect. They're going to complete a 5x3 data table, form their model, analyze it, and discuss their conclusions with the class. From this discussion, they're going to see, hey, when I tested surface area, absolutely nothing happened. There was no effect. We can safely conclude that surface area has no effect. And again, that will come out within kind of step 4 and step 5. Then I will do a mini picture and they'll have the application stage after that. Then once they have that, and once they know, hey, force of friction is equal to mu times Fn, which we will get not only from the lab, the discussion, but then the mini picture, I do want to do an application piece with this. And this is where I think I've really lacked in the past. So students will be given the option of creating a PSA that is going to look at how does the frictional force affect your driving, or for the students who say, hey, well, I still think having a bigger tire means bigger force of friction, they're going to do kind of a research project and exploration as to why the bigger tires do not provide more friction because of surface area, but on the mu coefficient level. So I have a couple documents attached to the discussion. I have the two options, and then I also have the handout. Thank you for your time. Hope you enjoy the lab.